Hello, everybody, and thank you for joining us for Postgres meets Iceberg, Bridging, Transaction, and Analytics. My name is Pavan, and I'll be your moderator for the session. Just a heads up that we will have time for a brief Q&A after the presentation, so please be sure to use the Ask the Presenter tab to ask any questions and engage with your fellow attendees. And with that, I want to welcome our speaker, Onder from Crunch Data, and go ahead and take it away, Onder.
Yes, thank you. It's great to be here. So yeah, today I will be talking about two important technologies, Postgres and Iceberg, and how we actually, bridge them together. And a bit of myself. So my name is Onder Kalacı. I'm from Turkey and I'm living in Istanbul. So I'm actually a long-time Postgres database developer. So I've been developing Postgres and related technologies like more than 10 years now. I used to work in a company called Citus Data, which was then acquired by Microsoft. And at Microsoft, I continued developing Postgres. And the main project that I contributed was Citus, which is a distributed Postgres with sharding. But I'm also new to the Iceberg community. So this is actually the first event that I'm attending with Iceberg. So I'm on, like 1.5 years ago, I didn't know anything about Iceberg, but now I joined a company called Crunch Data, where we are building a data warehouse on Postgres, which we call it as Crunch Data Warehouse, which blends Postgres and Iceberg into a single unified platform. So here is my agenda. So I will first briefly introduce Postgres because, I mean, this is an Iceberg event. I'm not sure how familiar listeners are about Postgres, but I will just give enough context to, frame the rest of the talk. And then I will talk about the two different worlds of database system, OLTP, like transactional systems versus OLAP, analytical systems, and how they come together. And then the main part of the final part of the presentation is bridging Postgres, the transactional system, with analytical system, Iceberg. And I will talk about why we need this and how we achieve that. So extensibility here is important. So if you are coming from another database background other than Postgres, extending the database might sound a bit unusual to you, but Postgres is designed extensibility in mind, and this is actually what enables us what we are doing. And simplicity is very important for us. So we are bridging two is the OLAP or analytical performance. So Postgres is designed for transactional workloads, and I will talk about how we achieve analytical performance. And finally, I also want to finish the presentation with some practical guides. So I don't want to leave it in a theoretical level, but also show you what it really looks like in practice, what I talk about. So let's talk a bit about Postgres to give you more background. So Postgres is probably one of the fastest growing database ecosystem out there. So you can see this from many different data points. So for example, on the top we have a chart which is DB Engines ranking, which ranks databases according to their popularity, and that orange chart is Postgres. So it's gaining momentum over year, and it has a very strong momentum. It's just keep going like that. And for example, another data point is the chart below, which is Hacker News job posting for different database systems. And the blue line is PostgreSQL, so it's leading with a very large margin. So it actually shows how widely Postgres is used in real world. So all I know, Postgres is very popular, gaining more popularity, and it's becoming more and more the default choice for transactional workloads. And then you might ask why Postgres? So there are a lot of reasons for that. So first, it's established and reliable and secure database. So from small startups to very large enterprises all rely on Postgres. it's actually incredibly feature rich. So it has been building features years over years, and it's like almost whatever feature you need is already in Postgres. And there's really no central owner of the system. So there's no central owner behind the Postgres project. So it's distributed across many companies. And this is actually, I think, very important point, because there's no one pushing their own agenda into the project, but rather the community is listening what users really need, and prioritize based on what's actually needed in this project to succeed even more. And as I mentioned, so extensibility. So if you are not coming from Postgres background, so extending the database might sound unusual, but Postgres is very extensible. So extensible in a level that you can inject different query plans or different execution strategies than Postgres would have choose. So you can actually build specialized databases on Postgres, but with a very deep integration with Postgres. So I will talk more on that. And then in terms of the feature set, so this is like on the right hand side, this is just to give you a taste of what Postgres supports, but there are a lot more than this. So I mean, basically, for example, it supports transactional DDLs, it supports JSON-B, which is serialized JSON, which you can also create indexes on it, which actually means you can also support NoSQL type of workflows in Postgres. It supports all sorts of SQL like CTEs, window functions, and whatnot. So, like in general, like it's a really extremely wide range of features are already included in Postgres, and it's just keep growing. So the innovation is continuing, and there's a very strong community behind that, and it's just gaining more and more features. Now, in this second part, I want to, briefly also introduce two different worlds of databases. So on the left-hand side, I listed transactional workloads, transactional databases such as Postgres and their usage pattern. And on the right-hand side, I added the analytical databases like Snowflake, ClickHouse, and Iceberg. So on the left-hand side, so for Postgres or MySQL, so the SQL and transactions are like the building blocks and the point of interaction with the users. And the query patterns is like typically you have very high query rates, like hundreds, thousands, or even tens of thousands of queries per second. But the queries are typically very small, like ingesting few rows, updating few rows, selecting few rows. And then the expected response times are very, very short. Like you typically expect less than a millisecond response times, or at most like few milliseconds response times is a very typical to get in the systems. And then there are typically user-facing applications. So for example, you buy something from a shop and that is recorded in a database. It's typically a transactional database. And because they are user-facing applications, they are typically like mission critical. You cannot afford any downtime. They should always be on. So that's why like replication and high availability and stuff are just part of the basic package for these database systems. On the right-hand side, we have analytical databases. They also provide SQL, and some of them also provide transaction support. But this time, the query patterns are quite different. So this time, like we are talking typically about like few queries per second, but queries are typically scanning large amounts of data. And to scan that large amounts of data, you typically need like parallel or vectorized query executions to achieve high scan throughput. And these databases typically power business-facing dashboards, reports, ad hoc queries and stuff. But they are typically, on demand. Like they don't always need to be up and running, but say like typically business hours is fine, and you can suspend your server or use serverless servers because you just don't always need them up and running. So I actually have two observations on these slides. So I think the first one is these two systems, although they look similar to the users because they provide SQL and transactions, they are designed completely differently from top to bottom, for all details, right? Like how the data is stored, how queries are planned, how executed, how indexes are designed, how caching works. So there are so many dimensions of building a database, and these two systems are designed completely different, I would say. But on the other hand, we are at a time in the history that you can take a database which is originally designed for OLTP systems, Postgres, and extend it to actually enable analytical capabilities on itself in a very clean and integrated way. So which is actually what we do, and what Postgres extensions or extending the Postgres, brings us to the table. And that's actually how we achieve what we are doing today, which I will go deeper. And then the question is, why do you need to, merge these two systems? Why do you need a data warehouse on Postgres? So because many teams start with Postgres as their system of record, and soon after, the data grows, they want to gain insights from this data. So they start adding dashboards, analytics, BI tools, and whatnot, sometimes directly on the same database, sometimes on the replicas, but they just keep growing the database. Why? Because Postgres is familiar, Postgres is easy to use, Postgres is versatile, Postgres just gets the job done. So people just don't want to leave Postgres. And I think one of the major reasons is simplified data stack, right? So no one really wants to add multiple tools to their stack for the analytics, because moving to another database means you probably need some third-party ETL tools. You need to learn that. You need to handle all sorts of failures while moving data. You need to, learn the analytical system. There are different gotchas, and there are a bunch of things that you need to learn. But people wanted to keep it simplified, and we typically call this as accidental data warehouse, because people don't start data warehouse in mind, but they end up with warehouses in Postgres. And another data point to add here is that, so as I mentioned, I worked on Postgres for a long time, and the main system we developed was Citus, and Citus is a large-scale transactional database. But then at least 1/4 of the users coming to us were in the accidental data warehouse situation. So they grew their Postgres databases. They are searching for ways to scale, but they are not searching for scale for transactional part of the equation, but they want to scale for the analytical parts of the part of their stack. So this is actually pretty common, and we have seen this a lot in the Postgres users. And then the question we asked was, of course, what if Postgres wasn't just your starting point, where you generate the data, but also your warehouse too? So that's actually where we see Iceberg and Postgres as a great fit together. So they are actually complementary use cases, right? So Postgres is designed for transactional workloads, or LTP, and Iceberg is designed for analytical workloads in mind. And then that's good. They are complementary, but more important thing is that they also share a very common foundation. So they almost speak the same language in the architectural level. So they both support transactions, right? If one of them is not transactional, then this would be impossible to work them together. And they both support transactional and flexible schema changes, like adding columns, removing columns, and so on. So if this wasn't available, then the integration would not be as smooth as possible. And also the data type support, right? Both of them support structured and semi-structured data types, so which actually is very important to be able to use these technologies together. And then this is actually how we see this, how we see all the picture in Crunchy Data Warehouse, and how we think we can bridge the gap between these two systems. So on the left-hand side, we have Iceberg, so which brings the foundation for fast analytical queries. And on the right-hand side, we have Postgres, which is versatile, feature-rich, and very robust database system. And in the middle, we have transactions, data types, and schema evolution, like which can be used for bridging these two systems. And now I will double-click on the left and right sides of this picture. So I think the first part I want to talk about, Postgres meets the power of Iceberg. So, Iceberg is designed, or as I said, Iceberg is, creating the infrastructure for fast analytical queries by its statistics, by using Parquet and lots of stuff. Like, it's designed for analytical queries. And then there are very advanced analytical capabilities that Iceberg provides. So for example, you can have time travel queries, which is like super powerful thing, or you can have partition evolution or hidden partitioning, which are actually great for analytical workloads. And also, for example, you get, by default, it's very typical to use Parquet as the data format. So which you get compression and columnar storage almost for free. So these, which are like very important things to for analytical systems, and Postgres can just rely on Iceberg on benefiting from this. On the other hand, we also see that then Iceberg also meets the power of Postgres. So Postgres is like very features complete, right? So there are functions, stored procedures, triggers, or all kinds of relational database features that are in, and there's a huge ecosystem of extensions. For example, one of the most famous extensions in Postgres is PostGIS, which is geospatial types for Postgres and geospatial indexes and whatnot. And so when you use Postgres with Iceberg, you can actually utilize the power of PostGIS even for Iceberg tables. And lots of data integrity constraints are by default provided by Postgres, like not null check constraints and stuff. And for example, fine-grained data access control. So you can have, for example, like multiple users and multiple tables and views, and you can just tell Postgres, okay, which user should be accessing which table, which column, even which row. So that's a very, that's already, in Postgres. And then you can, of course, create materialized views or views on top of, Iceberg tables, which are, just native Postgres things in Postgres. And I can make this list go very long, but I just wanted to pick like some of the things that I think very interesting to combine with the power of Iceberg. So all in all, like how I see this is like, it's not like one way or one part is benefiting from the other part, but it's two-way integration and two-way benefit for both sides. And then I think about why we ended up building Crunchy Data Warehouse, but also I think the question is, how can we achieve that? That's also an important question. And the short answer is extensibility of Postgres. So as I mentioned, like if you are not from Postgres background, extending a database might sound unusual, but if you are from Postgres background, extensions are just out there and everyone uses it very frequently. And just to give a meaning of extending database. So for example, as a user, you can connect to the Postgres terminal and you can just create new types, new functions, new aggregates, new operators and stuff. So as a user, you can just extend what the database can do with your own goals. There's further, there are a lot more things that you can do actually. So for example, you can load some shared libraries, like a library that can be loaded into Postgres server, which are called as extensions, which actually can provide different query plans and execution nodes to Postgres. So like instead of, okay, in your extension is you can tell Postgres that, okay, when you see this table or when this condition happens, instead of using the query plan that Postgres generated, just use the plan that I provide to you. And similarly, just use this execution strategy that I provide instead of what Postgres would normally do. And you can, of course, read and write data that resides outside of Postgres. And this is actually very common. Like from Postgres, you can read and write from S3, MySQL, Snowflake, whatever like that. You can read and write from files and whatnot. So it's also very common that you can read and write data from outside of Postgres. And I think the last one is also probably like now becoming more obvious. You can also read and write in any data format you want. So Postgres just provide hooks, and extensions can hook into this and actually change like a lot of things that happens during query planning and execution. So extensibility enables what we can do today. And then maybe another perspective on the extensibility, it's not like it's still Postgres, right? It's a very deep and clean integration and maintainable integration. So it's not a fork. So there are lots of Postgres forks out there for building analytical systems. So some of them are, based on ancient Postgres versions. So which means that they do not, benefit from the new innovations happening in Postgres community. They are not Postgres anymore. They generate their own syntax sometimes. They invent some syntax that is not supported in Postgres. So they are just creating a parallel universe in a sense. But if you stay within the extension ecosystem, then you benefit from all the features of Postgres and all the innovation. And adding a new Postgres version support is typically like a few days of work, and you just become in the Postgres ecosystem. And then when I mention extensions, so for example, in this Crunchy Data Warehouse project, we have a fleet of extensions. I think we have 7 or 8 extensions powering this whole experience. So for example, we actually implemented Iceberg spec in a Postgres extension written in C. So there's an extension we call Crunchy Iceberg, which knows the Iceberg spec and knows how to generate metadata and manifest files and stuff. And for example, we also have an extension called Crunchy Map. So Postgres doesn't have map type in the core system, but you can easily add that with an extension, and we created an extension called Crunchy Map. And we have several other ones. And then the top level or a little bit more complicated extension we have is the Crunchy Data Warehouse extension, which is the one which does this very deep and clean integration with Postgres by injecting hooks and creating different plans and execution nodes and stuff. So all in all, extensibility of Postgres is what enables us what we are doing. And as I said, simplicity is especially I care a lot about, because now we are talking about 2 systems, and each system have its own pros and cons and lots of settings and whatnot, but we want to keep things simple. And let's be honest. So I think using Iceberg has a high entrance bar, right? So you need to think about managed storage. You need to think about storage, right? Where should I store? You need to provide some object storage. You need to deal with that. And you need to think about catalogs, and it's a complicated topic, right? There are lots of things happening. There are different catalogs and whatnot. So you need to understand a bit to use that. Also, some maintenance operations like compaction, snapshot expiration, file cleanup. They are not trivial to do in many Iceberg implementations that, as far as I can see. So what we aim was, and what we do is very simple Iceberg deployment. So we just provide managed object storage. Of course, you can bring your own bucket, but we just provide the object storage you want. And because it's Postgres, we just include the GDBC catalog in the same database, which is actually very handy. And we if you are again have Postgres background, so Postgres does this type of maintenance work in the background called via vacuum background workers. And then we just extended those background workers to do the compaction, snapshot expiration, and file cleanup for you in the background without you even thinking, or most of the time realizing what's going on. because we try to be, very cautious about not impacting the user interactions. So yeah, as I said, simplicity is very important. And the next slide is all-up performance, right? So I mentioned that, Postgres is designed for transactional workloads. Then and then performance is important, right, in analytical systems. So like the question is like how we achieve good performance in Postgres. So I think the first answer I would give is caching. So Iceberg is great because the files are always immutable, so it is great for caching. And then NVMe drives are now, not that expensive. So NVMe drives are, you can think of it as fast SSDs, so with higher IOPS and lower latency. And they are, now available on major clouds, and they're not that cheap. So what we did is we just cache frequently accessed or recently accessed data in local NVMe drives, which actually makes a real difference in production systems. And then the second important thing we did was integrating Postgres with DuckDB as well. So I'm not sure how familiar DuckDB is to you, but DuckDB is like SQLite for analytics. So it's like a library you load into a process, and then it gives you SQL, which is very similar to Postgres SQL syntax. And under the hood, you can do parallel and vectorized execution, which are crucial for getting good performance, all-up performance, analytical performance. And then as part of the extension fleet we have, one of them is actually, using Postgres with DuckDB. And to give it a little bit more, visibility on what's happening. So like as a user, you go to the Postgres terminal, you just write a SQL queries, whatever. And for example, here, we are selecting from a table called records, and assume that records table is backed by Iceberg. And then what happens is that on the Postgres with the extension APIs, we realize that, okay, this is a query on Iceberg table. So instead of creating the plans that Postgres would normally create, let's create some different query plans and some different query executions. And then within that, within extension APIs, we also decided, okay, this table has, we fetch the latest metadata from the Iceberg catalog. We've used the data file pruning and partition pruning and whatnot, and we decide which Parquet files are needed. And then we delegate some part of the work to DuckDB that lives inside the same Postgres process. So we just do, if you're familiar with DuckDB, there's a read Parquet function call. We just delegate the whole query or like some parts of the query to DuckDB, and then let DuckDB either fetch the data from NVMe cache if already cached, or otherwise fetch from S3. So I actually really like this flow because at the top we have Postgres, at the bottom we have Iceberg, and in the middle we have DuckDB, which is used to accelerate the query execution and the match to all our performance that users need. So I think I talk a lot about why and how stuff. I also want to give you with some practical guide on like what it really looked like in practice. So let's start with something simple, right? So it's just creating a table in Postgres. So you just do create table. You can use things like serial, like constraints of not null and default values. The only thing that is different that you should be doing is marking this table as Iceberg with the using Iceberg syntax. So when you do that, we recognize that this is an Iceberg table and we treat differently when it's used. But as soon as you create an Iceberg table, we immediately record that into the Iceberg catalog that lives in the same database. And it's actually super handy to have this catalog in the same database, right? So you can query that, you can add auditing, you can do whatever you want. Like you have the freedom of SQL, and you can do whatever you want within the database on this table. And I think it's very handy to be accessing Iceberg catalog from the same database. And I think I briefly touched about this, but when you do this kind of deep and tight integration, so these Iceberg tables become like a first-class citizen in Postgres. So it immediately supports the full SQL, and this is not only select queries, like it also supports insert, update, and delete and stuff as well. So you just get full SQL support. You get transactions, joins across multiple tables, which I will double click a bit. For example, you get triggers, you get prepared statements for lowering query planning times. You can do create table as, you can do alter table commands, you can use nested types, constraints, you can create views, materialize views, you can use sequence. I mean, this list goes long and long, but the idea is that when you make these tables that are backed by Iceberg a first-class citizen in Postgres, then you get all the Postgres feature set that are at your that you can use on these tables. And this is actually one of the things that I enjoy and like a lot. So because everything is transactional and it's very natural for Postgres to do transactions, you can actually, in a single command, move data from a Postgres table into an Iceberg table. So for example, here we have a CTE, which deletes rows from Postgres table and returns the rows to the insert statement. And then you can just return those rows into the Iceberg table. So, and then this is atomic, this is transactional. If anything fails, we'll roll back everything. And we even remove the, orphan files and whatnot. And this is just, a simple example, right? You can also start a new transaction. You can say begin, and you can modify multiple Iceberg tables. You can modify multiple Postgres tables. You can join them, and you can do whatever you can do in Postgres without considering whether it's Iceberg or Postgres table. So you get like full transactional system that is available cross tables as well, and also cross Iceberg tables and multiple Iceberg tables as well. And that's just outcome of being first-class citizen in Postgres. And then the previous slide was on the transactional side, but you can also do that for selects, right? So you can just combine any Postgres backed or Iceberg backed tables. For example, here we just use union command, but you can do joins, subqueries, CTs, whatever, multiple tables, and you can join them direct, etc. So it's basically becoming a first-class citizen for the select world as well. And one another thing is this maintenance jobs, right? So Postgres also needs to maintain its heap, like Postgres tables, like the regular Postgres tables, and that's typically done by a background worker called auto vacuum worker in Postgres. And then we actually extend that capacity to also do critical Iceberg maintenance operations such as compaction, snapshot expiration, or orphan file cleanup. Just happens automatically in the background in the auto vacuum worker, and by default we do it on every 10 minutes. And that's why we don't, that's why you just don't need to think about this stuff at all. You can of course tune them based on some settings, like how there Spark has, for example, lots of parameters to tune, and we also expose similar set of parameters so that you can decide on like how the compaction and snapshot expiration or orphan file cleanup happens. But the good thing is that they happen automatically, and you typically don't even recognize that happening, because we try to be a lot less aggressive in locking things and let the user not understand that this background processes are happening. And then my last slide on the practical guide is, so Crunchy Data Warehouse is available as a managed service on all major clouds. It's part of the Crunchy Bridge managed service that Crunchy Data provides. And it's also available in Kubernetes and on premises with the, again, Crunchy Data's has a Postgres operator, and it's now available in that as well. So overall, I think this is my summary. So, I mean, we really believe that Postgres, I mean, Iceberg on Postgres is uniquely simple and really seamless way to harness, power of Iceberg. And Postgres and Iceberg are both complementary and compatible technologies, so that's why we can do it. And Postgres is extensible, really making it suitable for integrating with Iceberg. So I think that's all for me. And
Awesome, Onder. Thank you so much. If there are any questions, please drop them into the chat on the right-hand side. You'll see a little chat option. We'll give it about a minute or two here, Onder, to see if there are any questions do pop up.
mm-hmm.
You got lots of kudos. Okay. It seems like we don't have any questions. So once again, thank you so much for joining us, Onder. As a reminder, all sessions will be available on demand later today. Up next, just so you guys know, we have track 2, and we have best practices for schema evolution in Apache Iceberg, making your data future-proof with Rajesh Valia at PRA Group, and we'll see you there very, very soon. So once again, Onder, thank you so much for your time. Truly appreciate it.
Thank you. Bye-bye.
Bye all.